So some other things that your body makes that they have been able to create inside of bacteria using recombinant DNA or putting this human factor into bacterial DNA is that they have created human growth hormone. So athletes these days, bigger, stronger, faster. Anybody who works out really hard knows that if you take a shot of human growth hormone, that can help you to achieve results that you never would have been able to get naturally. And I think that as far as athletics goes, it's not really legal to do because it's seen as having an unfair advantage. And also it causes some health risks that they're not really comfortable out there with. Erythropoietin, I believe, is blood doping. And what that is giving your blood extra oxygen, because if you take in extra oxygen, you're able to do more work and lift more weights and run faster and work out longer. And so blood doping, which I think is something that's pretty, maybe you guys know this, it's pretty undetectable unless they know what your red blood cell oxygen levels are. It's illegal, but it's something that people do. And a lot of times they do it during training, but they won't do it during the actual contest or the actual event. And it helps them to be able to train longer and harder and faster and get better, and then try to not look like they're doing anything during the performance. So I kind of go back and forth. Should this be illegal? Should it not be illegal? You know, I'm of the scientific mindset of like, well, if we can do it, let's totally do it. But what's going to happen to these athletes down the road? Is it going to hurt them in some way that's going to be a long-term problem? What? When it causes lung disease and all that? Oh yeah, it can cause all kinds of diseases. But if these people assume the risk, should they be allowed to do it just because they can? I mean, it is money, not just to the medical companies, but to the athletic associations, and you know, what you do in your personal time, it affects a lot of the monetary decisions. So it's really interesting. On the other hand, it also takes a lot of money to detect these things. So there's money in doing it, and there's money in trying to prevent it. It's interesting. So gene therapy has come a long way in helping to diagnose and prevent diseases. So we can take certain types of genetic tests to find out, like, if you know that you have certain diseases in your family, you may be able to find out if your children, your offspring, are going to have them. You may be able to find out that you may have something like heart disease running in your family or cancer running in your family. If you've heard anything about the breast cancer gene, now that it's detectable, it can almost tell 90% whether or not you could get breast cancer or not. So now we can tell people that they're going to get these diseases, but we may not be able to do anything about it. So you think personally, just because you might know that 40 years down the line you have the genes that are going to give you cancer, but you can't do anything about it, would you still want to know? Would you want to worry for 40 years knowing that there's nothing you can do about it?
Well, if you were potentially getting breast cancer, couldn't you just have them removed?
Right, like Angelina Jolie had the breast cancer gene, but so it says 90% you have the gene that's going to cause breast cancer, but what if she was in the 10% who wasn't going to get it? Now they have the mastectomies that they can do. What if, should she be allowed to have children that she's then going to pass the genes along to her children? I mean, think about that. If I knew that I had cancer in my genes, would I want to have a child that I know then is going to have cancer as well? So just because you know about it and you can't do anything about it, do you still want to know?
Is that like the sickle cell
Sure. Yeah, absolutely. If you know that you're going to have sickle cell anemia, there are certainly treatments for it, but there's no cure for it.
Like if you, because we did research on it in high school, but like if you have the trait and you, like if your spouse has it too, the child could automatically have
Exactly.
sickle cell. It's automatically a high risk.
Right.
And if you know you have the trait, but like say if your spouse don't, would you like, is that the same thing?
Then you have a 50% chance of passing it on. So then do you still have children if you know that there's a 50% chance? Who gets to decide whether 50% chance is enough? Like, should we be allowed to tell people, should I be able to say to you, don't have kids, there's 50% chance that they're going to have sickle cell? Or who gets to decide that? Like, what if your insurance company finds out that you have a 50% chance of passing that along to your offspring? Then what if your insurance company says, I'm not going to pay for any treatments because you knew that was going to happen? Once the insurance gets a hold of it, then what if you don't have insurance? What if it's the government? What if the government says, Amy, I know you're going to pass on diabetes to your child. It's not true. I have type 1 diabetes, not type 2. What if they know that I'm going to pass it along to my child, so they say, we're going to sterilize you. So should they get to decide things like that? Who gets to decide? And if you knew you were going to have a disease that you're going to pass on to your children, should the government decide you don't have children? Should you decide you don't have children? Or since there's no cure, do we just not find out? It's really a interesting ethical and moral and legal question. You know, it takes you back to the Holocaust and the time of thinking that people had inferior genes. And so if you were blonde-haired and blue-eyed, then are you the only ones that get to survive? I mean, there goes, like 99% of all of us in the room. So who gets to decide those things? It's really a fascinating question. So it's something I could talk about forever.